Hey, Education Box here. Welcome back to another video. In this video, we will be going over pi, all of its uses, where it originated from, and interesting facts. However, first let's take a look at these few numbers. So, I'm sure everybody knows what pi is. Pi is equal to, it goes like 3.1415926, and then 535, and so on. Then, we have e as well. It's similar to pi, as in it is an irrational number. So e goes something like 2.71828, and then 1828445, and so on. Now, let's think of this. What is the square root of -1? Well, that's not possible, because no number can multiply with itself to get a negative number. And these are called imaginary numbers, which can be written in the form of I. So I is equal to the square root of -1. So now, what if we take all of these three complex numbers and put them into one? So let's take e to the power of pi times I. And now, what are the two most simple numbers? Well, 0 and 1 are, since they're the first two numbers. So if we add 1 to our equation, we actually get 0. Now this equation that we have created is fascinating. This is called Eulers Identity. It is compared to a Shakespearean sonnet and is described as the most beautiful equation in maths. Now this is because it mixes such complicated numbers with such simple numbers to get also such a simple number. So basically e to the I pi is equal to -1. However, in today's video, we won't be going too in depth of that. We will be just focusing on pi in this video. Okay, so let's go over the basics of pi. So pi is equal to 3.14 approximately, and that can also be written as the circumference over the diameter of a circle. No matter what the values are, they will always be approximately 3.14. Okay, so now let's talk about the circumference formula of a circle. So since the circumference over the diameter is approximately pi, that means that the circumference is equal to pi times the diameter, which can also be just written as pi d. Now, since the diameter is 2 times of the radius, it could also be written as pi times 2r, which could be written as 2 pi r, which is what we mostly know the formula of the circumference of the circle is. However, it could also be written as 22 over 7, since that also approximates to 3.14. Okay, so let's talk about pi as a letter. Pi is actually the 16th letter of the Greek alphabet. But why is it the 16th letter of the Greek alphabet? Why does it have things to do with a circle? Well, let's go into Google Translate. As you can see here, I put the word perimeter, which has something to do with a circle. So, as you can see, the first letter is pi. Now let's try putting something like the circumference. Now let's see what the first letter of this is. It's also pi. That's just something interesting to point out to see why they might have used pi to denote 3.14. So here are some key points. The perimeter is equal to the circumference of a circle. The circumference formula is pi times d, or 2 pi r. Pi can be written as 3.14 or 22 over 7. Now, with that in mind, let's move on. Okay, so now let's talk a bit more about circles. So, first off, we have the original point that we started with, which can be called the center or the origin of a circle. Next, we have the distance that we use to draw all of the equidistant points that form a circle, which is called the radius. This is very important because it is the difference from the center point of the circle to any other point of the perimeter of that circle. Another important circle dimension is called the diameter, which is the distance across the circle. As we can see, the diameter is exactly the same as two radius lines drawn in the exact opposite directions. Now, since a circle is a special type of shape, instead of using the word perimeter, we use the word circumference, which is the distance all around the circle. Okay, so now let's talk a bit about pi's properties. So, we know that pi is an irrational number since it goes on and never stops. However, it is also a transcendental number, which means that it is not the solution of any non-constant polynomial equation with rational coefficients. Now, like all irrational numbers, pi cannot be represented as a common fraction. However, every irrational number, including pi, can be represented as an infinite series of nested fractions called a continued fraction. So, a continued fraction is a fraction whose numerator is an integer and whose denominator is an integer plus a fraction whose numerator is an integer and whose denominator is an integer plus a fraction, and so on and so on. Now, this may sound a little confusing, so here's an image of it in pi's case. Pi can be expressed as 3.14 or 22/7. However, here are some more approximate fractions. So you can have 333 over 106, 355 over 113, 52,163 over 16,604, 103,993 over 33,102, 104,348 over 33,215. Now we can see that all of these fractions approximate to pi. Now pi also has some celebrations. Now you may be wondering, well, when would that be? So take the first three digits of pi, 314. Now we can see that the third month of the year is March, and 14, 314. So Pi Day is actually celebrated on the 14th of March. And on that day, usually people have competitions where they try to recite as many digits as they can. And here are some people who recited the most digits. Now here are some fun facts about pi. So there's actually a pi language. So this language is known as Pilish, in which the numbers of letters in words match the digits of pi. So there's somebody called Mike Keith who wrote a book called Not Awake. And as you can see in this paragraph, all of the number of letters in each word corresponds to the digits of pi. We know that pi is an irrational number, which means that the number of digits it will have is infinite. However, ever since it was discovered, humans and machines have been calculating many digits of pi, and so far have discovered 31 trillion digits of pi. And 31 trillion is an extremely big number. Now, 1 trillion is still an extremely big number. 1 trillion seconds of ordinary clock time is equivalent to 31,546 years. Now imagine 31 times of. Now this means that it would take 977,926 years to recite all 31 trillion digits of pi. That. And now imagine 1 trillion pennies stacked on top of each other. That would make a tower about 870,000 miles high, the same distance obtained by going to the moon, back to Earth, and then to the moon again. Now that means if we stack up 31 trillion pennies, it would go up to a whopping 26,970,000 miles high. And now here are some very interesting coincidences. So, I'm sure everybody knows Albert Einstein, but do you know when he was born? It actually turns out that he was born on March 14th, which is Pi Day. And I'm sure everybody also knows Stephen Hawking. And guess what day he died? March 14th, 2018. And with all of this information, that would just about wrap up this video. Hope you learned a lot of things from this. And as always, thanks for watching.